Hello everyone, today we're going to talk about Cisco 300-425 exam review. About 591 Lab, it is the top IT training and certification exam brand in China, Hong Kong, Taiwan, Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in either Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. Today we're going to talk about the Cisco 300-425 exam, or ENWLSD, designing Cisco Enterprise Wireless Networks, which basically covers site surveys, wired and wireless infrastructure, and mobility, and wireless LAN high availability. We're going to take some questions that we see in such exams and how we can tackle those questions in order to solve and pass the exam. For example, we have this question about what is the main reason why the Wi-Fi design engineer took a different approach than installing the APs in the offices, even though the installation provide better coverage. So we can see here in the pink, it's the executive offices, the CEO, the CEO of the company, basically the most important offices in the company, yet we do not see any access point. The red dots or the red circles are the access points. We can see that he installed them in the corridor and in the white offices, which are the administrative offices. So the reason behind this, I can think of like these are the most important offices in the company. Why is the reason he did not install any access points inside of them? Let's see the options that they give us. Basically, okay, option A, aesthetics, meaning that it looks good for better, like if it looks good inside the office or not. Transmit power considerations, antenna gain, and power supply considerations. So let's eliminate wrong answers first. I'm gonna start with the transmit power consideration. When we talk about the transmit power, it will not, regardless of the position of the AP, it will not change. So we should not consider this at all. It should not change whether we install it here or in the far corner. So we can eliminate definitely that option. Antenna gain, again, it's not going to change whether we put it in the executive offices or not. It's not going to change. So that's definitely not an answer. Power supply considerations. Power supplies mean how we provide the power to the access points. So basically, whether we provide it using power over Ethernet, PoE, or whether we use a power injector to the access point, it should not change. It did not explain why we did not put an access point inside these offices. So the only reason I can think of in this situation is the aesthetics. And the reason is this: these are the VIP people of the company. Their offices are very clean, very important, that need to have a very clean look, a very, like, we do not want to show any access points, any equipment, so we do not install. So basically, he did not install any access point inside of these offices, which makes sense, because these, like I said, VIP offices, we do not want any equipment to show, any cables, anything else to show in these areas. So the right answer is A, aesthetics. Let's go to the next question. A customer has determined that aesthetics is a primary concern. So aesthetic, again, our main concern for the design, not coverage, not anything else. I mean, those are important as well, but this is our main consideration for this design. Is the primary concern for their upcoming guest deployment? Which design consideration can be leveraged to address this concern? All right, like we did before, we need to eliminate wrong answers first. So let me check one answer at a time. Paint the access point to cover the LED from being noticeable. Okay, interesting. However, The LED in the access point can be easily disabled from the controller. There is a specific option in the controller that disables the LED for specific access points or for all access points. So we do not need to paint over the access point in order to cover the LED. We can basically disable the LED option from the controller. So I don't think that this is the correct answer. Use enclosures to hide the wireless infrastructure in the surrounding environment. This is really interesting. Okay, let's keep it on the side. Use Air AP bracket -1 to allow for greater mounting locations. I really want to show you this Air AP bracket -1 so you can have an idea what I'm talking about. So this is the air bracket. It will not make the access point look better. Basically, this is what we use to install the AP on the ceiling or on the wall. So it will not make it look better. This is just a tool so we can screw the access point against a wall or a ceiling. I don't think this is the correct answer because it will not make it look better. It will not give us a better aesthetics. The fourth option we have is the deploy environmentally friendly cabling components to blend into the environment. I do not believe that using environmentally friendly cabling will make the AP look any better. It's definitely better for the environment, of course, using environmentally friendly components, but it will not make it still. It will look like a bulky AP with some cabling coming out of it. So definitely it's not good for aesthetics. The only good option that we have is using enclosure to hide the wireless infrastructure inside the surrounding environment. So let me show you one of the enclosures that we basically use in order to hide the access point and make it smooth with the environment around it. So this is one of the enclosures that Cisco uses in order to hide the access point inside of the ceiling tiles. It has very smooth with a key, no cabling whatsoever showing off. So it's very clean, very good looking. It's very good aesthetics. No cables showing, like I said. It's really good. So this is definitely the answer. B, using enclosures to hide the wireless infrastructure in the surrounding environment. Next question will be, multiple WLCs are implemented in high availability. So multiple access points. Okay, multiple controllers. That means it could be N+1 or more than one controller. Okay. And high availability configuration in a mobility group, APs are deployed with only a primary controller assigned. By default, which mobility group member controller do the orphaned APs join in the event of failed controller? So an orphan AP means that an AP that does not have controller at the moment. It could be that it got disconnected from its controller, or you just deployed it or something. So to which controller it will choose? A controller with the most available free license capacity, the most license capacity, or lowest percent of associated APs per license, or the controller with the least CPU utilization over the last reporting period. Okay, interesting. CPU utilization. All right. Controller with the least number of associated APs. So we need to know here what is the actual steps that the APs go through when it gets disconnected or it needs to join an AP. And in order to see this, we need to check the Cisco guide on how the APs in such a mobility group deployment and high availability deployment will act like. And basically this is taken from the Cisco website and on how the APs are joining. You can perform AP load balancing in 2 or more WCs, such that the one we have. If you configure mobility groups properly, the web allows for dynamic redundancy and load balancing. For example, if you specify more than one IP address for option 43, an AP sends discovery request to each of the IP addresses that the AP receives. In the WLC LWAP discovery response, the WLC embeds this information. First, information on the current AP load that the controller have, the AP capacity of that WLC, and the number of the wireless clients that the controller is connected to. The AP then attempts to join the least loaded WLC because it makes sense. It does not make any sense to check for, I don't know, free license or something else. Of course, if it does not have a free license, it's not going to join, but it's not a priority. It's basically going to check which is the WLC with the greatest available AP capacity. After an AP joins a WLC, the AP learns the AP of the other in the mobility group from its joint WLC. So basically, the AP will join the controller with the least number of associated APs. So the one with the least load, basically. And the answer is D. Next question is, a wireless engineer is using Ekahau Site Survey, a tool we use for site survey and designing Wi-Fi, to validate that an existing wireless network, existing wireless network, this is important, is operating as expected. So he's auditing the existing wireless network. He's not doing designing from zero. No, it's an existing wireless network. Which type of survey should he use to identify end-to-end network performance? GPS assisted? I don't think so. This is basically used for outdoor surveys, and it will not check to audit an existing wireless network. Spectrum analysis. This is great when we want to see the spectrum analysis, the radio frequency of a network. If we have interference in Wi-Fi, if we have like a microwave interference, if we have something else. And it's the same, almost the one we use with the passive survey. The passive survey basically performed with a listen-only mode, which basically only listens in order to check for bugs, locate RF trouble zones quickly, validate final RF settings, perform initial surveys. So it's not good for our situation because it's an existing wireless network. So the only option that we left with and makes sense is the active pin. And the active pin is performed with the survey client associated to the AP. So it's actively connected to the AP and doing some pings to ensure from client to the end, to the server or to the other IP address that it's checking the speed or something else. So we use active ping in this case. Next question. An engineer is using Cisco Air 2702 AI AP to conduct a layer 1 site survey. Layer 1 site survey. Which mode is selected for the AP to discover non-Wi-Fi interference with MetaGeek channelizer? So we're using a channel analyzer to check for layer 1 site survey to see if we have any non-Wi-Fi interference. This is interesting. So let's start with this one. Okay, so both of these, I can see that SE-Connect or FlexConnect is both used to serve clients. In this case, we are not looking to serve any clients. We do not care. We just wanted to check if we have any interference. So we're going to use the Air 2700 in order to check for non-Wi-Fi interference, not to serve clients. So definitely it's not going to be either B or C. So it makes sense to choose either from monitor or sniffer mode. Okay, so sniffer mode basically will capture the Wi-Fi packets and store it in something like a Wi-Fi file. It will show us the packets over the air, but it will definitely not show us any other Wi-Fi interference. It's not going to show us like you have a Bluetooth device, you have something else. No, it's just going to show us some packets that the other devices are contacting between them. So it's not going to help us in this situation. It's used in other troubleshooting situations, but not in this one. So the best mode that we can use the AP here is the monitor mode. It's basically going to listen over the Wi-Fi to see in the spectrum, like we said before, the spectrum analyzer, it's going to check if we have non-Wi-Fi interference, such as Bluetooth devices or non-Wi-Fi devices sending and interfering with other network. So definitely it's going to be answer A, monitor mode. All right. Thank you all for your attending today's class at 591 Lab. We hope you find this material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day.